Question 48. Everybody just hang out. I'll remember my name. And then shit. Did I type that in right? No. Yes. Okay. That's amazing. What section again? Sorry.
4.2.
4.2. Okay. Bam, bam, bam. Bam, bam, bam. All right. Stop. God, why am I so zoomed in? What? All right. And then which problem, Kelvin? I'm sorry.
Question 48.
48. Damn, 48. Oh, yeah. Okay, okay.
So, some of us
Holy shit.
interpreted it one way, and others interpreted it another way. Some of us thought that it was a piecewise function, and then others just thought that the megabytes and the prices were just 2 points.
Oh,
You can throw me in the bus. It's
No.
okay.
Oh.
okay. So if you ignore this for a minute, well, I mean, okay, what would this mean? Assuming this is linear, they tell me eventually it's linear, right? What would a flat monthly fee of $10? What would that mean mathematically?
That slope would be 0, and that's just a flat fee of 2.
No. Okay,
Y-intercept?
that's the y-intercept. So this is how much they're paying per month. They have to pay $10 period just for the service, right? And then on top of that, they pay a certain amount of money per megabyte. So if you go for a whole month and don't use your phone at all, you still got to pay. And of course, if you use, so in this plan, if you use data, you got to pay as you go. Does that make sense? Okay, now, what's trippy about this problem is they seem to give me the y-intercept, but then they give me 2 points worth of information, yeah? 20 megabytes, so let me see. If you just find the answer using the points, I'm curious how it came out.
What section did you say it was? 4.2?
Yeah.
Let me see if it works in my head, let's see. Yeah, that'll work. Okay, sorry, let's double check. So everybody, does it make sense that the 10 should be the y-intercept? Because what's my input variable? Let's start this. What's my output variable? Price, the cost, yes? What is the cost dependent on? What's my input variable? The amount of data you use. Yes? You with it? Now, if you use 0 data, how much do you have to pay?
$10.
That's why that's the y-intercept, 0, 10.
But now the question says, so what's throwing me off is it says per megabyte.
Yep.
And then it says if the customer uses 20 megabytes, then it will be 1120. So that means, in my head, that if you use over 20 megabytes, you're gonna pay a flat rate fee of $11.
No.
So
No. All right, let me see if you're with me on this. I'm going to say something and tell me if it makes sense. Because the first thing I realized when I looked at this, you could, if you wanted to, take $10 out the way. How much did they pay for the 20 megabytes then? They paid 10 no matter what. Then they used 20 megabytes of data. How much did they pay for the 20 megabytes of data, period? If they paid $10, right? They paid $10. Then because they used 20 megabytes, they paid a total of 1120. Take 10 out. How much did they pay just for the megabytes? 120. You with me? Yeah. I think that's related to what you're thinking about, possibly. The $10 is in the 1120. You don't have to solve it that way, though. What does a person pay for it? They pay $10 no matter what. So the person that used 20 megabytes, they paid $10 no matter what. Plus what to get it to $11.20? $1.20. Now, do you have to drill down to that level to do this problem? Shit, no. What are the 2 points? Does anybody see 2 points?
0, 1.2.
Do it again.
0, 1.2.
No. Okay. Sort of.
Use the 2011 to 20.
If a customer uses 20 megabytes, the monthly cost is $11.20. So what point is that?
20, 11, 20.
20, 11.20. Does that make sense though?
Yeah.
Don't shut up. Just realize.
I was gonna say you can make it 0 and then the other 110.
But it already gives you 2 points.
But then your inputs will be 20 less than they would be. So if somebody's like, what if I use 50? Then you got to go, oh, I should plug 30 in because I took 20 out. You see what I mean? So you're making your equation work but harder to use, which is an option. An option that the government seems to go with. And then what's the other point?
130.
130.
Comma 1780.
1780. So then you can get the what do you get from that? From the 2 points you can get slope. And what do we already have? Y-intercept. Is that okay? They gave us 2 points worth of data to get the y-intercept. I'm sorry, to get the slope. They also gave us a y-intercept, which kicks so much ass. But you're right, you have to realize it's the y-intercept. So you already know B, and now from these you can get M. And then you can piece together your equation. Okay, cool, I like it. I like it. Well, and that's beautiful. I want you to realize, let me see. The fact that you're frustrated is good, because this is not a straightforward problem. And the opposite, if you weren't frustrated, that means you didn't give a shit. And that's why you're not frustrated, like, I don't care. So I'd rather want you caring. But do you guys, does it make sense to everybody now, how to look at this? It's almost like they gave us too much information in one way.
They did.
They did. They didn't have to give us the $10. We could have figured it out. But they gave it to us, and we're like, oh. And then you get to a point where you're worried, do I have to take, no, 10 is B. 2 points, get the slope. Right? Okay. Is the rest of that problem okay after that? Or somebody is like, I don't know, I didn't get past part A. I'm sorry. All right, let me know if there's anything else about that one. Any other ones? Yes?
On 3.3, number 10.
Do. Okay. Number 10? Okay, there you are. What is asking? Let's see. Find the average rate of change. Oh yeah, these are worse than I wanted to be. That's okay. We'll all survive. All right. Let me erase this stuff. I'm sorry. What's another name for average rate of change? Slope. Good. What do I need to be able to get the slope?
2 points.
2 points. Great. Did they give me parts of points? Yes. So I have x, comma, who knows? And x plus h, comma, really, who knows? This first one's easy. If the input's x, what's the output? 3x squared minus 2. Is that cool?
Is that just what we put for the...
Yeah, totally.
Oh, okay.
What would you do if I gave you a number for x? You would plug it in, yeah?
Yeah.
So then if I have an input of x, the output is 3x squared minus 2. What if I have an input of x plus h? What's the output?
3x
Yeah. 3 times replace, look at me trying to erase my cursor. Replace x with x plus h minus 2. Okay, and then this you could,
Maybe x squared plus h squared. No. Oh.
don't lose your middle term, right?
Yeah.
Yeah, square can't distribute across addition.
3x squared plus
xh.
plus 3x squared
Yeah.
minus 2.
Kick ass. This is the construction approach again. It's one of my favorite things because in order to do this, I have to construct the points. And how do I construct the points? Input, output, okay. Once you get that simplified, then you just get the slope. Now listen to me say, just get the slope. So this will be, whatever you hear will be y2 minus y1 over x2 minus x1. Trust the process. We care that it's kind of gross. They didn't give me numbers. Damn them, right? The process don't give a shit. It says take your output minus output divided by input minus input. Is that better or no? Okay. Worst thing is when I make it worse, when I explain stuff.
For 5, is it asking you for the y-intercept? Or, because it says b. So am I supposed to plug b in?
Oh, no. Literally, one input is 1 and the other input is b.
Okay.
So f of 1, you get a number. F of b, you get 4b squared minus 7. Yeah. Something to look forward to if you haven't done that yet. Hopefully most of you guys have looked at those problems at least, okay? I'd say right now, to be really on track, you should definitely be in chapter 4. Okay. Or, we also go back to 3 to do some stuff, so I mean, you should have gotten a little bit in the format. Yes?
So 5.1 is the last one, right? Or did we not?
Yeah, if you look at the homework sheet, the first test goes through 5.1.
Okay.
And we have to finish up a couple things. Yes?
So for number 98 on 4.1, this is a really stupid question.
Awesome.
But I was wondering, do I have to make my domain in my graph, make my domains 10 by 10?
You said 98?
Yes.
Okay. All right. Oh, okay.
Especially like specifically for the y-axis.
They've tried to prep you for this kind of problem. If you plug it, oh shit, sorry.
I mean, I got the problem.
You definitely don't have to, in fact, you should not have a range of -10 to 10 or something.
Okay.
You want your range, you want the y min to y max to mimic the largest and smallest outputs you would get, yes? So if you plug in -10 and you plug in 10, that gives you an idea of what to set your y's to, what your range would go. Does that make sense?
I just wanted to know how you wanted it particularly, because I know the question specifically said you have to have a domain of 10 by 10.
Yeah, we've seen problems like this before, and they were worse because they were like cubes and cube roots and shit. And all you did was you plugged in the extreme values to see what the extreme outputs and what the extreme outputs would be, right? Same thing here. They just didn't say that.
Okay.
Like, oh yeah, we've been getting you ready. Now here. So yeah, this one, if you try to put it a full 10 to 10, it's gonna be very almost flat. Yeah, it's not gonna be very good. Poor little guy. Is that all right? I did give out a copy of the graphing calculator instructions. Yes. Okay, good. Go past Jeff. I think you had to do 99 also. Is that right? Yeah, so 99 is going to be the other way around. If you go 10 to 10, it's going to go like straight up. Because there's a big outputs and large slope, you're going to want to be able to see way up. Okay. Is that okay? Screw you, Jeff. Yes.
2.5, 54.
2.5?
2.5.
Good, okay. 2.5. And I know we bounce around a lot, but again, the curriculum is created, and then I chose this book to use, so it doesn't really line up perfectly. Number, which one?
54.
Okay. Normal systolic blood pressure for a man age A. Does anybody here age A? No? Okay. You're age A? Okay. Is given as P equals blah, 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 blah. Find the age to the nearest year of a man who's normal blood pressure. Okay. Sorry?
That's what I said.
What'd you say?
It's like,
Oh! Well, That's exactly what the formula is. I don't know what you want. Of course you would say that. Okay, guys. The specific numbers and all shit doesn't matter. So I got P represents what? Pressure, blood pressure. A represents age. They want to know the age. So what is it I don't know? What variable? I don't know A. And trust me, it's the easiest thing in the world to throw 125 in. And then of course you're like Guinness Book of World Records territory. So slow yourself down, really pay attention to what the variables mean. Therefore, will I plug 125 in for A? Hell no, because 125 is a blood pressure, yeah? So I plug it here. Yeah, okay, beautiful. Then what do I do?
So like a quadratic,
Yeah, well, what do you have to do first? This will be 125. Subtract 125, and then you know what A, B, C are. Yep.
We did that and we
We got some really messy ass numbers, and we weren't really sure where to go.
Yeah.
So either we screwed up or we.
So this will be -5, right?
Mm-hmm.
Okay. So A is 0.006, B is -0.02,
Mm-hmm.
C is -5, right?
Yeah.
So it'll be B squared minus 4 of these, 4 of these times these. This will be -5, okay. You'll have to show me, I don't know. What did you get? Did you actually get like a decimal?
I only got as far as that.
I stopped here.
Interest rate. Oh, well, put it on calculator, shit.
Ah,
Well,
Bum,
maybe
bum,
pretty much
but then is it, you're gonna be
5 months.
0.00034 years old.
What? Let's see.
Maybe.
Wait. Oh, yeah. Okay. Yeah, that was about right. So that's.
You did decimals too.
That's like 3 years old.
Yeah.
Even less.
Yeah, yeah.
Well, I don't know.
Yeah.
Yeah, okay. 12 before, yeah, the square root of that's roughly right. Yeah,
I mean, like,
yeah, okay.
simplify this into one
I don't
number?
see a mistake. It could be a mistake on their end,
That's hairy.
because it looks like it was roughly 3 years old. You got 2 point something?
I didn't even finish it because I wasn't sure.
And then I'm worried about this kid.
Exactly.
Yeah, what 2-year-old?
Of a man, I'm like,
Blood pressure.
kid sitting there with a cigar going, what is blood pressure, doc? They're 3. What's going on? Almost 3, doc. Donation. I don't know. They could have made a mistake when they set that up. I'd have to do it myself and check to see what it is. I don't see an immediate mistake on there. I didn't really look at yours, so.
Thanks.
Anytime. That's what I'm here for. To occasionally be helpful.
And 55. I went below.
55. Recall that profit is revenue minus cost, kids. Set up a quadratic equation, find 2 values. Okay, blah, blah, we'll create a profit. Okay. How do you get the profit function? All right, so listen. I am the last person to ever want to teach business. This is the highest level of business I want to teach. Revenue is the amount of money you bring in. Cost is the amount of money you flows away from you. Yeah. So to find profit, it would be revenue minus cost. So you would take this function minus this function. Yes.
Mm-hmm.
Then you would put your like terms together, and what kind of function do you end up with? Quadratic. So set up a quadratic equation. Okay, cool. You're going to get that once you subtract those 2 things, right? And then they want 2 values that will create a profit of $300. So you set your equation equal to 300. So it's a lot like the systolic pressure one, and hopefully you don't get weird answers. Is that okay? Okay. Did you have more specific issues? Oh, okay. Well, Figure it out and give it to me and I'll see what happens. Yes?
What if my calculator won't simplify it a radical for me?
What? Oh, you've got an HP or something?
Or a Casio, yeah?
Oh, Casio's not as bad. HP's are
Like,
weird.
if I put this in, it won't move. If I say, you know, the square root of 20.24, it gives me that. And I can't figure out how to make it
Oh.
be a decimal.
There's settings or mode somewhere. Anyway, alright, you have to show me at some point. Yeah. Of course, you can always Google Casio user's manual.
Yeah.
You go ChatGPT and say, hey,
Jeez.
I got I'm not a HP, got a Casio. And then it's gonna say, I don't know either, I'm sorry. Okay, anything else from homework stuff? If I haven't helped enough, let me know. I don't wanna do too much, and if the issue is the answers you're getting, then you have to kind of show me the work. It sounds like you got the right idea of how to set it up and work it out. That's what I'm concerned about showing in class. If the problem is I get kind of weird answers, I have to sit down and look at it with you. Okay. Anything else from homework stuff? Okay. How you guys doing? You guys doing okay? All right. I love you guys. Okay. So let's do this. We got a little bit to finish up from about quadratics. What I want to do, actually, can you guys just tell me anything that we know about quadratic functions?
They're parabolas.
Okay, good. One graph look like, or,
There you go.
okay, that's one bit of information. Good job.
It's awesome, Jeff.
They typically give you 2 real answers.
What is that? I don't know. Okay. So when you were okay. Anything else?
They typically-
Not all from the same person.
I'm
Sorry.
sorry.
You're good at it. I was like, I'm gonna take it out.
What'd you ask?
Say again?
2 answers.
You're welcome.
2 answers when what, Kendall?
We saw it.
Solve what? I don't have an equation.
It's a 0.
Good.
You owe me $20.
You got it?
Yeah, no problem.
Gotta be surrounded by people that wanna help you. I like it. So if I have this, then there must be 2 answers. What could be true about them? Good Lord, Jeff.
They could be from what?
This is from the fundamental theorem of algebra. Oh, okay. What could be true about the 2 answers I get? Both answers could be
Real.
real, or both
Complex.
complex. Or I could get one repeated real, but that's actually, we consider that to be 2 answers. They just happen to be the same number.
Awesome sauce.
Okay, I appreciate that. Anything else about quadratics?
I don't like
How do you find the vertex?
Minus b all the way to a.
Yes. So the vertex is xy, x is negative b over 2a, where of course b and a are determined by the numbers in the right place. Okay. A is not the first number you see, a is in front of x squared, so be really careful they give you something that's out of order. Something that math people really enjoy doing. I'm one of those, yes.
On the practice test, it says to state, one of the problems says state the vertex of an equation, or a function, excuse me, and then to verify it by using the shortcut, which I'm assuming is that one.
Yeah, that's the shortcut.
So.
What we still need to do tonight, one thing we have to do tonight is figure out how to put it into vertex form. And I haven't talked about vertex form yet.
Well, so when it says state the vertex, does it mean use that?
No, we're gonna use what I'm gonna show you here in a bit. I haven't shown it to you yet.
So that's the shortcut.
That's the shortcut. Yeah. Okay. Anything else? How do you know if it's opening up or down?
A is negative, right?
Yeah, if A is negative, then it opens
Down.
down. If A is positive, it opens up. Okay. And just to make it a complete story for you guys, y equals x squared is this or this, right? Y equals ax squared is this or this. X equals y squared is this or this.
Right.
We're not going to look at those yet.
We're gonna look at x squared plus y squared equals
Yeah. Why are you still on, like, I don't know. Okay, all right, that's good for now. So, I'm gonna try to tie a lot of things together, and then you're never gonna believe it, I have a handout.
Yes.
No way.
I think I do. There it is. Okay. So, oh, not yet. Sorry, Marie. Maria's like, give me something to do, damn it, Jeff. Suck. I know. I've accepted that I suck. So, yeah. So if I have this, guys, if I have that function, that's the basic problem, right?
Yes.
Where's the vertex?
0,
0, 0. And then if I wanted to, I could do -1 and 1 to give myself, and then bam, bam. Okay. Now, what would happen if I did that? Look at it as transformations.
Right uno up dos.
Yes. When it's in with the letter, you do the opposite of what it looks like. Because I really, students eventually, that night we did transformations, it seems like everybody kind of got it, but it's one of those ideas that if you don't think about it for a while, you're like, why does that make sense? Every input I put in has to be one bigger than they used to be. Because what's the first thing I do to the poor things? What's the first thing I do? Take one away, yeah? If I plug a 7 in, what do I do first? 7 minus 1. You guys kind of with me? So if I want to get the same output that I would have gotten up here putting a 7 in, what would I have to put in there? An 8. So that, I need you to see. It's the fact that I'm taking one away, I have to force all my inputs to be one bigger than they used to be. That's why it moves right. So it's a counter move to the -1 that's in there. Whatever the shit that is, this is just going to straight up add 2 to every output. And that's why that just goes up 2. It's a very easy to forget thing as to why those do what they do. So you have to stay on top of that. So can anyone tell me where the vertex is for this? Without graphing it, without doing any other work, where's the vertex? Where did it start? Before I applied any transformations, where was it? 0, 0. How did it move? Right 1. So where is it now? 1, 2. Okay. So you're never going to believe. You're never going to believe what we call this form. We call this form a vertex form. Because we're just so smart. So watch this. If I have a quadratic that is in this form, why is it h and k? I actually have no idea. I think I looked it up once. It wasn't because Howard and Kenny were working on this, but it could have been. Can anyone tell me what the vertex would be? HK, kick ass. So if it's in, I need you to notice, what if I had a line in this form? What can you tell? Slope? Y-intercept. So there's this thread through a lot of mathematics. If I have a function and the graph looks a certain way for the function. If I put the function in a certain form, physical aspects of the graph come out. Lines, slope, y-intercept. There are physical aspects of it. Where does the thing start and how does it move? Physical aspects of the graph. If I put a quadratic into that form, out pops the vertex. Also, what pops out? What does A tell me? If it's opening
Up or down?
up or down. I'm not sure how into this I'm going to get, but the bigger A is, the skinnier it is. Because I'm multiplying by A, so if I multiply by 10, it's going to go up higher, quicker, yes?
Yeah.
So if A is 1/3, then it gets really wide, yes? Okay, so it not only tells you if it's opening up or down, it also tells you how skinny or wide it is because of how quickly or slowly it's going up.
Yes, King. Whatever you say.
No. We're not going to do that, whatever that was. Oh, okay. No,
Whatever you say, go.
that did not feel good. Don't do
I will follow you to the ends of
that.
the
Shut up. I control your grade, shut up. Okay, that's on camera. Show that to my dean. Give me a drum. Okay, so the real good question: getting a line into this form, I would hope everybody in here would say that's easy. Just solve for y. What do you do? Getting a quadratic in this form is a little more involved. Would you agree? Probably, yes. So, for example, if I have this, what do you got? Let's start off not too crazy. What you got, buddy? Hello, buddy. All right, here we go. So I want to put this into vertex form. Notice I don't have two sides of an equation, correct? This is not an equation. This is a function definition. Are you with me? Before I do this, let me see. Oh, man, all right. I'm not even going to try to do that. If you have $5 currently, right? And I take $5 from you, eventually I have to give $5 back to you, right? If I do that at the same time, that's kind of dumb. But maybe you're asking like 5 ones from me. So you're at a cashier, you know, you have change for a 5. So you give them $5. They better freaking give you $5 back. Maybe it's 5 ones. That would be great, right? Not 20 quarters. It's crazy. So, what was all that about? I don't know. Is there a process? Remember, our goal is this form, yes? Do we have a process to make a quadratic look like this? No? Not really. Let me start off the process and see. Make some room.
I'll complete the square.
Complete the square.
Nice to meet you.
So what's the first step of completing the square?
Half a beat.
All right, good. Right? Is everybody with me? Cut 6 in half, and you get 3, and then you square. This is what has to be added. Now watch. Do I have two sides of an equation?
No.
No, I don't. I have a function definition. I don't have two sides. I can't add 9 to both sides. So what I'm going to do instead is like I just said. If you give me, if I take $9 from you, I should have said that backwards. If you give me $9, at some point I better give you $9.
Yeah.
Overall, what did I just do to the equation?
Nothing.
I did nothing. Yes?
Sick.
Way to go, Jeff. But I've reorganized it. So how, I don't know if you guys are really with me. This is always a little trippy. And I try to use Indiana Jones as an example of this because how many people have seen Indiana Jones, the first movie? It's okay if you haven't. It's not a prerequisite for the course. I'm not going to get out of it. No. But there's a scene where he's got a golden idol and he's got a sand thing, right? And he thinks he takes out enough sand and he does this. He basically takes 9 away and adds 9. But does he actually add 9? I think he adds 8.9. And so the boulder comes. So if you don't balance your equations correctly, boulders could come at you, okay?
Oh, Lord.
There could be some spears coming. I don't know. I don't know. You signed up for the class. I don't know. Very small print at the bottom of self-service that says, some boulders might crush students. Okay.
All right.
How do I factor this piece now? That was fun. Remember this? Yeah.
Yeah.
This tells me how to factor. And what's negative 2 minus 9? What's the vertex?
Oh,
shoot.
Whoa. Negative 3, negative 11.
Yeah, negative 3, negative 11. Yes. Shift back 3, down 11. Yes. So, yeah, it all happened at the end, right?
Yes.
Really quickly, which is great. And that was way better of a reaction than I thought it would get.
That was great. Yeah.
Yes.
You got to see that x minus 3 by 2.
How to get what now? Sorry.
The x minus 3. I mean, the x plus 3 squared.
Oh, that's how this factors. And I don't even have to think about it because this always tells me what number goes in.
Okay.
Okay. You guys semi with me?
Minus minus 3 is due, yeah.
Can you guys tell me the y-intercept really quickly without doing any work? Yep. Huh? Oh. You can't tell in this form easy. Because how do you find the y-intercept? You make x. If you make x 0 here, you have some work to do. But if you make x 0 here,
There, and it's
negative 2.
-2.
Let me stop for a minute, right? This form gives me the vertex easy. The original form gives me the freaking y-intercept easy. Okay.
That's great.
Now, let's graph this.
Stop.
Or, I could just not show you and then test you on it.
Oh, that's great.
It's always an option.
Yeah, sounds good.
Okay.
As long as I don't have to do it.
So then, moving on. Does anyone else want to see it?
Yeah.
Yeah? Okay. Sorry, I'm sorry. You're like, is this guy gonna actually, what the hell? I'm sorry.
I have successfully sabotaged the class.
So, do you notice the vertex is negative 3, right? So it's gonna be back 3, down 11. So I can be smart. Most of my stuff's gonna exist over here, yes? Alright, so let me set up a decent, so 1, 2, 3, 4, 5, 6, oh, that should be plenty. Nobody will be seated during the amazing scale creation. Let's see. 2, 4, 6, 8, 10, 12.
Well, that's how smart man is, right?
I want to be like you when I grow up too.
Alright, it'll happen. So, is everybody with me? So, we have control over the scale, and it doesn't have to be the same scale in the x and y, but it better frickin' be the same scale, like on both sides of 0. Are you with me? So you can make this a scale of 1, and you can make this a scale of 2, or a scale of 80, or a scale of whatever the shit, yes? As long as it's consistent on its own axis. We're the humans. We can make these graphs do what we need. So plot the vertex. Some of you guys are like amazing. Some of you guys, so much shit you can do in your head. I love it. Just ain't writing shit. All right. So the vertex, negative 3, negative 11. So it's going to be about right here on my graph.
Yeah.
Where's the y-intercept?
0, -2.
0, -2. Now let me ask you this question. Dear God, that's not the answer. Yes. It's not a straight line.
What?
We do know that's the vertex, but we really need one more point to anchor our graph. I don't want it to be all freaky on this side, right? Poor little thing. Where's the mirror going to be for this? Where's the mirror always? It goes right through the vertex. In fact, we call it the axis of evil. No, the axis of symmetry. The axis of symmetry.
You got me there for a second.
I know. Runs right through the vertex, yes?
Yeah.
In this case, it would actually be x equals negative 3. That's the equation of the line that goes straight to that. So if there's a point right there, and this is where the mirror is, where's there a mirror image point of this? 1, 2, 3.
1, 2, 3.
1, 2, 3. I like how some of you guys are like, keep going. I'm like, I'm waiting for you to tell me what to do. So we just do that right over poor little negative 6. And now we got, and then we got, that's pretty good for me. That's really good for me. Still sucks, but it's pretty good. You guys got it with me? Y-intercept, if it's in ax squared plus bx plus c form, it's easy. Vertex, you have to put it in a vertex form, or if I let you do the shortcut. If I don't say to do the shortcut, you have to use completing the square. I will on the test say, put it into vertex form. I don't think I said it on the practice test, so that's what I meant.
That's what the handout's for.
Yeah, actually, I'm glad you said that. So let me give you this handout. I do this, I do it. I forget that I made a handout.
That's what
I'm making my own problem. Oh, sorry, man, I'm basically.
You should stop.
You never let Marie do it. You can't, wait a minute.
What happened? Oh, here, here. You did one to him, so you got, did you get one? No?
You have to do it. He needs one.
Everybody got one? Alright, so this is for future reference. So you can have this sitting next to you as you're doing your work. By the way, if somebody thinks about it, I do want to put up into Canvas all of the handouts I've given out so far. I kind of meant to do that, I just never think to go into Canvas. But if somebody reminds me, it's not your job, but if you think about it, remind me, I can put all the stuff up in Canvas. So you can go get a blank copy if you want at whatever point. This is really good to have sitting next to you as you do your homework. Right here, I do the completing the square we did. And then I kind of verify it with a shortcut. You guys with me? Even if I don't ask you to, if I were you, I would verify it with a shortcut, just to make sure I did this right. Look at this one. Here's a pretty one. This one gets tricky. Okay, so let me ask you this. You ready? All right, here we go. If I have this, yes?
Yes.
What did I do so far? What did I do to get here? Yeah, I took a 6 out, right?
Yeah.
So in the original problem, is there a 2x?
What?
Let me say this again. How did I get to this step? What did I do before this step to get? I took a 6 out. So in the original problem, there was a 12x.
Right.
Because there's not 2x, or 6 times 2x. So, if I complete the square in here, could somebody help me do that? How do I complete the square? Half of 2 is
1.
crazy. And then 1 squared is
1.
crazy.
1.
I add 1, yes?
1.
Do I subtract 1?
1. You add 1.
No.
You do not subtract 1.
What did I just do? Remember, is there an actual 2x here? No, there's a 12x, correct?
Yeah.
Did I actually just add 1?
You got 6.
I added
You
6.
subtract 6.
I gotta subtract 6. All right, let me say this again. Guys, be quiet just for a second. I didn't just add 1. Because anything I do is multiplied by 6. If I multiply this back out, and please don't do this, but if I do multiply it back out, I get plus 6. That's what I actually did. So out here, I better put minus 6. So overall, I just did nothing. I just reorganized it, right?
Yeah.
You guys are all with me? So when there's a number out front, I like to call it an amplifier. It's a multiplier. So whatever I do inside gets multiplied by that. Gets really trippy when that number is negative. So then how would I factor this?
Oh, x plus 1.
Yes, thank you. You just said 1 again. I was going to go crazy.
1.
1. And another one. All right. Okay. What's the vertex?
1.
Negative 1, negative 6. Get fast.
This one has an 87 and adding to it.
Say again?
The one on the handout.
Yeah, so there was an 87 already.
Yeah.
So I moved the 87 over. I took a 4 out, yes? if you cut 10 in half, you get -5 squared is 25. So I had to add 25. Now what did I actually just add?
I don't know.
So I better subtract 100 at the same time.
Oh, with the, oh, okay.
And then 87 minus 100 is the -13. So then the vertex is 5. Okay. So can you guys do this?
Easy enough. It's crazy.
Call Mario for help. You can work with people near you if you want to. I'm not gonna throw you into groups, but we'll see.
Standard form is the melody for vertex form, right?
Yes. I try to use the vertex form. I think that's what this book says. Another book I used to use standard form. Sometimes it's just the first step you need help with. You know if you need help.
Try to replicate what I did on this one.
No, that should be full. And then
Oh.
So you were thinking too far ahead for that one step.
Yeah.
Yeah.
Maybe this one, where I put the other two. Yeah. -4 is from the 16. This one? It would be 8, but that's right. This one? Oh, on the bottom one right here.
Oh, okay.
Yeah.
Move the 87 over a bit, do yourself some minutes, and take a 2 out of the first 2 years, and then do some limits out.
Yeah, it's one. It's one.
Okay.
So use some limits.
So we want
And then so plus 3 outside.
so see how this is similar because it
Good.
doesn't like this one.
And now you apply
And
this.
then they factor it out.
Yeah.
Oh.
Yeah.
So try doing that here. Try
If
factoring
I
2
square this, I'll get
Oh, so put it like outside like that. And then,
if I square this,
so minus 4x.
square this, 25.
And is that when I do the, by that one?
Yeah.
The middle term or the other term?
Yeah.
And then do plus 3?
Double this thing.
Oh, so it's not the 8, okay. I see.
Oh, good.
So then I would cut this one in half and then square it.
Yeah.
So we use that to help us.
And
Half
choose
of
the
this tells me
4?
what
Alright, so what do we get?
needs to be in here.
Then 4 divided by 2.
Tells me what number has to
2.
be out.
Then square 2 times 2 is 1.
So you look at
So
B
This is what we
and
observed
then
to
just
create
do step
this
1
process.
first, where you
And
put
then
it
the y
in
intercept
and
is
get that
0.
number. So write down step 1.
We take half a negative
Mm,
or minus
so-
gone, minus the half.
Yeah, let me see what you did.
First step is we got that
Small
negative
writing
one.
here.
What?
Mhm.
Negative one.
Alright, yeah, so then we're gonna put the square on
Then
that
you
side,
square
so
what you
right?
I'm just.
And then here,
Yeah, I forgot you don't have to subtract this out. You can
outside.
Wait, which one?
After this
So I keep the 3 that was there originally? Or, okay.
So you.
So add before here and
Now, what
then
did you actually just add?
Exactly.
on that side as well?
Add it to the outside, but remember, you need to
No, you
multiply
add
it by
two.
this and subtract it.
Because is there
So
really a
whatever you
negative?
add
That's
in here,
twice that,
subtract
there's
out.
negative.
This next one you're hitting.
So when you put
Plus
plus
4?
4 here, what did you
Plus
actually
4
just
times
add?
2, because factor this out, so you have to factor
Plus
back
8?
out.
Undo
Yes.
that at the same time.
But it'll be minus.
That's the trickiest part.
And do you know why?
No.
Because whatever you add, you have to subtract, so that you basically end up with no changes.
Oh,
Oh, I see, I see.
so when you put this in there, so.
Come
Oh. Several things. That can't be in there, or else you would have taken the 2 out.
And then
So
we
you
use
see how
that,
you move that last number?
and
just
then I
get
guess
it
we
out of the
simplify
way.
it. it and get vertex bar.
Can we do that? That's all, that's the only one.
That one I was gonna put you in a group.
Just rewrite the
Okay.
numbers and
Sounds
show
good.
how you simplify.
But yeah, you can start looking at the back. I mean, what can I do?
You might throw us in jail for that.
I might,
You might throw a boulder at me.
The
Who knows?
reason I did this
I did have that.
is because that
Wait, you friends with Wiley Coyote or something?
Maybe we both have the same idea.
For what?
When you square, that tells you what to hit.
That is your vertex bar.
And then the second step, it tells you what to
Almost,
hit.
almost. It's a negative 3
This
plus 5.
is where we get our numbers
Wait,
here.
is that?
From the first step you put in there.
Yes.
And then the
We
fourth,
get-
the fourth year
This
comes to that.
this last number
Easy.
is where we find this. Because remember how we added it here? We added these numbers together.
How'd you get to
We get that by finding this number here.
Then you would match.
Okay.
Now,
Here,
you
and then
gotta
it
counteract
the
what
whole
you did.
thing.
So that's, wow, answer to
So
like that.
now, this
That is
thing
your
always
vertex
has
bar.
always, the first step always.
So try finding the vertex, because now we have vertex bar.
I thought we were just being too negative.
You got what?
What? And there's always the opposite sign of this one, so it's the opposite of this one's always the same.
I don't
so it's-
control it.
The ones are everywhere.
I'm not sure why you changed the sign, but that's just what I.
Yeah, you're right.
Yeah.
Yeah.
Good job.
Wait. Might just write that? My one.
Yeah.
And that's a positive. Wait, do you have negative?
Because I did half of 4.
You must do it.
It
So, either way, it doesn't, not on that
Say
side.
if your input for X is
Yeah.
1 or something in this
Well, no,
function,
because
X
I,
of X,
at the very beginning.
if your input is 0,
Yeah, but once you square it, it becomes
What you
positive.
wrote is right, if you could have used eight.
The negative, the answer comes from how the,
Yeah. It's just whatever sign is in front of the 4.
Well, that's different. So my,
no, it's X minus 2 because you need a negative.
Yeah.
This is my positive.
Yeah.
Oh, should have paused this.
I thought the y step was 0, 3, and then I used the x symmetry to get the other point.
this is negative.
Unless I messed up.
So guys, I'm gonna catch up to you real quick, let's see.
Is that wrong or am I close?
I mean, you got 1 point right.
Oh, okay.
I
Anyway,
don't know how you got the other points because.
Guys,
you could do
If you go further in
Well, that's
mathematics,
the vertex.
completing the square has a few
That's why, so it
uses.
doesn't have to be that point.
It's already shown up a couple times for us, yes? So it's got more uses. It it is hardwired on having the first coefficient be 1. You guys with me?
like taking out.
No, but it's the same thing.
Yeah.
Oh,
So
okay.
if you have any coefficient on your x squared, you gotta take it out.
Okay,
No question.
Okay.
for any use that it's in.
Yeah, anytime you gotta use it.
Okay.
So then I take -4, cut it in half, and then I square that. That is the number I must add. What did I just add? 8, so I better subtract 8. This is always how this guy is going to
Oh, it's
back.
negative.
So is this one right?
So what's the vertex?
2 -5.
No?
No?
It's a point.
Yeah, 2 -5.
Oh, I'm sorry.
Yeah.
I just heard -5. 2 -5.
It sure does open.
I like that though. You gotta
Um,
advocate for yourself. You're like, excuse me?
Did you make that positive?
Yeah, he told us to change it. He said the typo was to be the same problem.
Yeah, I wanted it to be the same as this one.
Oh, okay.
Good job, Jeff. All it took was me to turn the paper and I forgot what the hell I was
Or
doing.
did you just take out 6? You took out negative 6. Interesting.
So we got the vertex
Well,
for
no, I
this.
took out 6.
2 -5.
Wait, you're supposed to take out a 6 or a negative 6?
I don't know, I just.
That's the thing.
I know that's.
What's the y-intercept for this?
3.
I'm just gonna take
0,
out
3.
6. And then it'll open back anyway.
So go ahead and finish up graphing it if you haven't finished yet.
You
Yes.
have to go to advance the question. Do you?
Yeah.
On number 2, yeah.
Wait, me?
Yeah, that's right.
Yeah.
Me.
Huh?
You're not sure. Is that your question? If you
You just take out a 6 or a negative?
-6.
Okay,
Just took out a 6, would there be a 1 in front of the x squared? No, there'd be negative. There must be a 1 in front of the x squared.
Okay, then well,
Okay, so it's.
when I graph it, each one.
Now, real quick, you ready?
And then,
When you put a +1 there, you actually just subtracted 6, so you better That's the tricky thing with the negative out front, you gotta be careful.
Okay, so when you take out the -6 and it makes this a positive 1, it makes this -2, right? Because you took out the negative.
Still an X there, right?
Yeah,
Give
that
yourself
would be
some
a-
room inside
Yeah,
for the other term.
yeah, but they changed
So
this
first
one
we
to
got two,
negative.
yeah, yeah, both.
That was my only question.
I got you.
Thank you.
What?
You got two.
It's 5. Rainbow 5.
Would be 6.2.
Yeah?
So it's, is this just 1, 5, right? So now we can open down
Yeah.
one line more.
And real quick, that one you got by counting,
Yeah.
And I don't have to go up by 2.
if you plug 4 in, you better get one
Mine
out.
still goes down by
So
2.
4 into X?
Yeah, you better get it.
Over 1 up.
I just made it go down by 2. So I was
That's the way to check.
No, I'm confused, what? How do
If
you
you
check?
input a 4, because every point on this graph does what? It makes this equation work.
Mhm.
Is that cool?
Yeah.
So if you plug a 4 into this
Yeah.
equation, you better get a
Yeah,
3
just
out.
ain't ready.
That's
Oh,
what
because
that
that's
point
the
is.
function. Oh, I see.
That's the
It's
point you
input.
found
Yeah.
just by doing this.
Yeah.
So if it works in the equation,
And it was bad.
it's really likely
Yeah,
you did
no,
it
so
right.
I- Go home, someone else.
Maria, say your handwriting's bad.
Excuse me.
If somebody did not think that, I would be concerned about it.
I think
It's like on the first day of class, I very often joke to any class I'm teaching, if you wanted somebody who wrote well, you've chosen poorly. And we'll get used to it.
See, sometimes the truth is okay. Sometimes being transparent is not that bad.
My students are learning the big lessons in this class, I gotta tell you.
The students become their teacher.
Of course, on the other side of this coin is sometimes telling the truth is not good.
Transparency is the best policy. Honesty is the best policy.
So guys, you gotta let me know if any part of this doesn't kind of make sense.
I don't like that negative 6.
Alright, do that.
So
Yes.
if it was,
So real quick, this is not like a major part of things. This is a little something, but the idea of completing the square shows up in a lot of places. So if you're gonna go any further in mathematics, it needs to be. So one reason we do this is because number one, you have to know what graphs look like. Number two, finding the vertex is a huge part of any problem, because the vertex is where things turn, things change. So I want to be able to find the vertex. And then, okay.
No.
So the vertex is 2, -5. The y-intercept is 0, +3.
Okay, yeah.
So where is there another point? How do I get to another point?
Mirror.
Mirror, how do I do that?
Count back.
1, 2,
We want 2.
1, 2. Would you say this is kind of a skinny problem?
Yeah.
Why does it make sense?
Because it's a 2.
Because there's a 2 out front, right? It was,
the two makes the rise actually.
yes. So that makes it basically become a little skinnier than standard, right? Okay. Blah, 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 blah. So this other point obtained using symmetry is just, you can always find the y-intercept. You always can find the y-intercept, and then it's just count over to the mirror, count as many steps over past it to find the reflection. Kick ass. Now, I have a feeling some of you guys have started this one. I do want to note there's a -6, so you got to be a little careful, but go ahead and try to do that. Feel free to work with people near you if you want to. Yeah, let me pause this. Oh, yeah, shit. All right, guys, let's see. So just to get practice, we can do the full completed square method. I've got to factor a -6 out, which is going to change the sign on this. And then the -1, we just sort of push them out the window. And then if I complete the square, cut -2 in half, square it. That's what I've got to add here. Now here's where everybody tripped up. just about. When I put a +1 there, I actually just subtracted 6. Because whatever I put inside here is affected by this 2. So when I put a +1, I actually put a -6.
Yeah.
So out here better go +6. So on one level, we just did nothing. On another level, I reorganized this so I can put it in a better form. And the better form tells me what the shit the vertex is, which is great. So then I get -6. This tells me how to factor this dude. +5. What's the vertex? 1, 5. Does this open up or down? Just out of curiosity.
Down.
Opens down. What's the y-intercept? I know that from the beginning.
-1.
0, -1.
Not bad, 0.
That's right. I mean, good, thank you. So then, if I make scale here, I think the scale could be 1s everywhere, right? Yes. My vertex is 1, 5.